Good day everyone, I am Arman Joseph F. Watko from BSc 2D, and today I will explain collision in two dimension using this example. So let's go. Sample number 1. Vehicle A with a mass of 1,500 kg traveling with a speed of 25 m per second collides at an intersection with a vehicle B with mass of 2,500 kg traveling north with a speed of 20.0 m per second. Find the magnitude and direction of the velocity of the wreckage immediately after the collision, assuming that the vehicles undergo a perfectly inelastic collision and assuming that friction between the vehicles and the road can be neglected. So, yung example natin, burahin ko na para makita lahat yung solution ko na mahaba.
Conservation of momentum. Initial momentum is equal to final.
For this problem, yung collision is perfectly inelastic. We only use the conservation of momentum in two dimension. Hindi natin gagamitin yung conservation of energy equation since the kinetic energy is not conserved. Pipili tayo ng coordinates. So, those coordinates before the collision, the only vehicle having momentum in the x direction is the vehicle A, while the vehicle B naman is carries all the momentum in the y direction. After the inelastic collision, both of the vehicles move together at some common final velocity na lang ang lalagay natin doon and an angle theta. So, yan dalawang quantity na yan ang isa-solve natin for this problem using the two components of the conservation of momentum equation. So, draw natin yung dalawang vehicle. Say, this is vehicle A, top view, and this is the vehicle B. Papunta sa north, this is our coordinate system. X and Y axis. This is the positive sides. Vehicle A is traveling at 25 meter per second with a mass of 1,500 kg. Pa-travel siya sa east or positive X direction, and si vehicle B naman is pa-travel pataas dahil north with the speed of 20 meter per second. Dahil sa north siya nagtatravel, positive y direction yun. First step, gagamitin pa rin natin yung conservation of momentum, initial momentum is equal sa final momentum. We find the x component and final momentum for the initial muna at x. Component is equal sa mass of A times the velocity of A. So siya lang yung nasa x component. We have 1,500 kilograms. Nung kanyang initial velocity, sa ilagay lang natin as initial na 25 meter per second. Initial momentum at x equal to 37,500 kilogram per meter per second. So, ito na yung ating initial momentum at x. Final momentum at x. So, dun sa final say, nag-collide na sila. Ito yung ating coordinate system. Ito si vehicle A, si vehicle B. After the collision, na nagbangga na sila, say, ito na silang dalawa. Ito na yung kanilang direction. Ito. with an angle theta. And since nagdikit na sila perfectly in elastic collision yun, velocity ni vehicle A and velocity ni vehicle B, final after the collision ay iisa na lang, kaya nga ang ilalagay na lang natin as the final velocity ito, and that is the velocity after the collision. And since nagdikit na sila ng kanilang mass, is pagsasamahin na lang natin. So sa final momentum at x component, pagsasamahin natin yung mass ni A plus mass ni B and multiply sa final velocity, ito siya. Since x component lang hinahanap sa atin, kukunin natin yung x component ng kanilang final velocity. Ito yung final velocity at x, and ito yung final velocity at y, at x ito, so x pa natin yung equation. Final momentum at x is equal sa mass A plus mass B times sa final velocity cosine theta. Ito yung ating equation na gamitin. Ito yung equation ng final momentum at x component. Substitute na natin yung value ng kanilang mass. Final momentum at x is equal sa 1,500 kilogram plus 2,500 kilogram times sa final velocity cosine theta. So final momentum of x is equals, ang mass is equal sa 4,000 kilogram final velocity cosine theta. At y component naman, initial momentum at y is equal sa before the collision, nag-a-act si vehicle B lang sa y component, so this is the mass of B times sa velocity of B initial is equal, ang mass ni B is 2,500 kilogram. Ang kanyang velocity initial is 20 meter per second. By calculating, ang initial momentum at y is equal sa 50,000 kilogram meter per second. Final momentum naman at y component, again, i-consider na natin itong final momentum after the collision. Ito, since isa na lang ang velocity and same process with the final momentum at x, itong sinolve natin na to, combine na yung kanilang mass of A plus mass of B times the velocity, final velocity at y component. So this is mass A plus mass B, final velocity sine theta. Nalalagay natin dito, substituting the values to simplify the final momentum at y. Mass A plus mass B is 4,000 kilogram, final velocity sine theta. And ito na yung equation natin for the final momentum at y component. To apply the conservation of momentum, let's use the equation here at x. Initial momentum is 37,500 kilogram meter per second is equals sa 4,000 kilogram final velocity cosine theta. Sa y component naman, we have 50,000 kilogram meter per second equals sa 4,000 kilogram final velocity sine theta. To solve for the angle tangent theta, equal to 50,000 kilogram meter per second divided by the 37,500 kilogram meter per second. So, pwede na natin i-cancel tong dalawang zero nila para makalas theta is equal to inverse tangent times 500 divided by 375. So, theta is equal sa 53.13 degrees. So, and since alam naman na natin yung theta, pwede natin gamitin of any of this equation. Pwede equation na to, or pwedeng na-derive natin kanina from y component 50,000. Dito na lang natin siya ilagay. 50,000 kilogram meter per second is equal to 4,000 kilogram final velocity sine theta. Solving for the final velocity, we divide both sides by 4,000 kilogram sine theta. Cancel. Cancel. So, final velocity is equals to 50. Final velocity is equals to 50,000 kilogram meter second divided by the 4,000 kilogram sine 53.13 degrees. By calculating, ang final velocity natin is equal sa 15.63 meter per second. So, this is the final velocity with an angle of 53.13 degrees. So, this is example for collision in two dimension.